So in this question, you have a container which is filled with water of mass 200 grams, okay? And the water originally at a temperature of 22. That's the starting temperature of the water. Then what you did, you put ice. So when you put ice, what will happen? Because water is a hot object and ice is at 0 degrees. So ice is a cold object. So heat always transfer from hot object to cold object. So this piece of ice will absorb energy from the water so that the water is losing heat. So water is losing heat and ice is absorbing heat. And as the water is losing heat, the water temperature decrease. And as ice is absorbing or taking heat, ice temperature will not change here because ice is at its melting point. So it will melt. And when the ice melted, now the temperature of the mixture after some time until we added 60 grams of ice. So we added 60 grams of ice to this. So water temperature will turn to 0. As it is losing energy, eventually it will come in thermal equilibrium with ice, and ice already melted. Now in this question they ask, so water temperature is changing. Whenever there is a change in temperature, you will, to get the energy or to find the energy, either you will use a specific heat capacity or heat capacity. So here in this question, the specific heat capacity of a water is 4.2. Calculate the thermal energy loss by water originally in the beaker. Because when ice is melting, the amount of water will change. The water amount will increase. But the thing is, the question they ask, compared to original value, what is the thermal energy lost? So how to find the formula for specific heat capacity is equals to energy divided by mass into change in temperature. So specific heat capacity, it's given 4.2. Energy we are finding. What is the mass of the water originally in the beaker? It's 200. Now what is the change in temperature for water? It started with 22 and the final temperature is 0. What's the change in temperature? So it's 22 minus 0, or which is 22 itself. So these are divided, other side multiply. So 4.2 multiplied by 200 multiplied by 22. What's the final answer? The ice mass is 60, so the total mass will be 260. But the thing is, in the question, if you see, they ask calculate the thermal energy lost by water originally in the beaker. So originally there was 200 gram. Definitely, when all of the ice is melted, then the mass of the water should be 260. But in the question, they did not say what is the total energy gained by all of the water or lose by all of the water. They asked by originally in the beaker, means in the beginning. That's why we are taking a mass 200, not 260. So it is 18,480. So this value is 18,480 joules. The next part, assume that all of the thermal energy lost by water originally in the beaker is transferred to the ice. So 18,480 joules is lost by the water and all it gained by the ice. Calculate specific latent heat of fusion of ice. So how to calculate latent heat of fusion? Latent heat of fusion or vaporization is energy divided by the mass. How much energy is there? It's 18,480. And what is the mass? Originally, the mass of ice was 60 gram. So 18,480 divided by 60, you will get joules per gram. Why joules per gram? Because the mass is in gram. That's equal to 308 joule per gram. So for each gram of ice, we need 308 joules of energy. Is it clear? Joule per kilogram or joule per gram, both are acceptable here. The reason is that because the mass is given in grams, so you can write your answer in joule per gram. If you want to convert into kilogram, joule per kilogram, that's up to you. Only thing what you have to do, you have to convert this 60 gram into kilogram. Divide by 1000 and then solve, you'll get the answer. Suggests a reason for inaccuracy in the value of specific latent heat of fusion. Like you're getting latent heat of fusion as 308 joule per gram. But in reality, this value is a bit higher. Like example, this value is about 320. Why there is inaccuracy? Why you're not getting an accurate answer? What's the reason? What might be a reason? So there are two, there you can mention your answer in two ways, because what happened here, what is our assumption? Our assumption is that we have a container which is filled with water, and this water is losing energy and the ice will gain energy. That is our assumption, that all of the energy which is lost by the water, that was 18,480, all the energy lost by the water is gained by the ice. But in reality, in practical, this will not be true, because maybe the ice might take energy from surrounding, the water might lose energy to the surrounding. So you should be specify, like you should mention, if you're saying heat loss to the surrounding, you should mention like heat lost by water to the surrounding, or heat absorbed by ice from the surrounding. So ice has absorbed some energy from surrounding, or water lose some of the energy to the surrounding. That's why your answer is not accurate. Is it clear? Actually, this is related to the topic density and latent heat. An ice hockey rink has an area of uh, 1800 meters square and the thickness is 0.025. The density is 920. Calculate the mass. So density is mass over volume. How to get the volume? This is the area and the thickness or height. So when area multiplied by thickness, you will get the volume. So volume is area multiplied by height or area multiplied by thickness. And density is 920, so that's 920. Volume is 1800 multiplied by 0.25, 0.025. So when you multiply, you need a mass. So it's 920 multiplied by 1800 multiplied by 0.025. What's the answer? 41,400 kilogram. So that's the answer for the mass, which is 41,400 kg. That's related to the topic general physics, in which density is mass over volume. How to get a volume? Because you have the area. If you have area of something, you multiply it by its height. Area multiplied by height will also give you the volume. And volume multiplied by density, you will get the mass. So which is 41,400. In the next part, this one is 41,400 kg. In the next part, the ice is at 0. To form ice water at 0, it's poured into a ring and then frozen. The specific latent heat of fusion of the ice is 3.3 exponent 5. This is not 105. This is a power 5 or exponent 5. Calculate the energy removed from water to form an ice. So how much energy is removed from the water to make an ice? So latent heat is energy divided by mass. So we need energy. Latent heat is 3.3 exponent 5. And the mass, because we want to make a ring for this ice hockey, the mass of it should be 41,400. That will give energy. This is divided, other side multiply. So 3.3 exponent 5 multiplied by 41,400. It will be a big answer. In terms of exponent, you should represent this answer. 1.3 exponent 10. Always write your answer in 3 significant figures, not 2 big answers. So 3 significant figures. Is it clear? When you solve 41,400 multiplied by latent heat, you will get the answer. In this question, a road is covered with a layer of a snow. The temperature of a snow is 0. The specific latent heat of fusion of a snow is 3.3 exponent 5. This is not 105. This is exponent 5 or power 5. The snow forms a layer of a uniform thickness on the road surface. Calculate the power needed to melt 0.12 kilogram of snow in 220 seconds. So first, to get the power, we should know the energy. So first we'll find the energy. So we have the formula: latent heat is equals to energy divided by mass. Latent heat energy required to change the state, that's 3.3 exponent 5. Energy E, and the mass is 0.12. So 0.12. So 3.3 exponent 5 multiplied by 0.12. What is the energy required to change this state of this ice or state of the So 39,600. 39,600 joules. This is the energy required, but in the question we need a power. So how much power we need? Power is energy divided by time. So you have the energy, which is 39,600 divided by time. So how much time it took? 220. So 39,600 divided by 220. What's the power? So 180 watt means you need 180 joules per second to melt this ice. The meaning, the term what here refers to joule per second, which shows how much energy is required for every second to do a work, or energy supplied each second. So you should supply, if you want to melt this ice in 220 seconds, so you have to supply energy every second. You should supply 180 joules, because the meaning 180 watt means 180 joules per second. So these are the similar questions you will find related to latent heat. Then you have to learn the experiments to find specific heat capacity. This experiment is very simple experiment, and you can work out this experiment from its formula. What is the formula for specific heat capacity? The formula for specific heat capacity is equals to energy divided by mass into change in temperature. This is a formula which we use to find specific heat capacity. But practically, energy, as we discussed yesterday, practically we use electrical heaters to supply energy. So what is the formula for energy when you use electrical heater? So that's equal to power multiplied by time. So the new formula for experiment, we use electrical heater. So as we use electrical heater, the formula for specific heat will be power multiplied by time divided by mass into temperature change. But power of the heater, as we discussed, the power of the heater is equals to voltage multiplied by current. So the new formula, the experimental formula for finding specific heat capacity is equal to VIT divided by M into temperature change. This is the final formula which we use when we are carrying out the experiment, that voltage multiplied by current multiplied by time divided by mass into temperature change. So normally related to this experiment, what they ask, you have to name the quantity and the apparatus used for that. Like example, V is a voltage, and which apparatus is used to measure the voltage? So we use voltmeter. And what is delta theta? Delta theta is a change in temperature. So you can mention it is final temperature minus initial temperature. Normally we supply energy using a heater. So it's final temperature minus initial. So V is the voltage. We use a voltmeter for this. I is the current. I'm writing the units as well, so you can recognize from their units. Voltage unit is volts or V, you can write. Current, it is ampere, A. And the apparatus which we use ammeter. T is the time. For time, the SI unit of a time is seconds. For this, we use a stopwatch. M is the mass. SI unit is kilogram, but in experimental procedures, it can be can be used. We use a balance. And T1 is a starting temperature. The SI unit is degree centigrade, and we use thermometer. T2 is a final temperature. The degrees, it's also unit is degree centigrade, and we use thermometer as well. So these are the apparatus and the quantities which we use to calculate the specific heat capacity for any material. How it is done, I will show you, but this is a simple way to get the specific heat capacity of any material. Take the screenshot, then I will show how it is used in experimental procedure. So example, in this question, a student is supplied with a small block of iron, thermometer, electrical heater of power P. So this time power is given. So if power is given, we don't have to measure the voltage or current because power is given directly. They mention power is P. There are 2 hole drills in iron block. This is a piece of iron. 2 holes are drilled. The heater fits tightly in one hole, and the student places a thermometer to the other hole. Figure 5.1 shows the experiment. Student use this equipment when determining the specific heat capacity of iron. So the question is the other equipment that student will need. What he need? Specific heat is equals to power multiplied by time. So specific heat is power multiplied by time divided by mass into temperature change. If power is known, you can use this formula. If power is unknown, then you have to find the power. Then formula is voltage, current, time divided by mass and temperature change. This is when power is unknown. But in the question, they mentioned the power of the heater is P. So what apparatus we need to do this? Yeah, so voltmeter, ammeter connected to electrical heater, stopwatch. So you will mention all the apparatus. It's a 4 marks. So the answer here, what apparatus we need or equipment we need for this. mention all of them. So equipment, we need voltmeter, ammeter, stopwatch, balance, and thermometer. This is the equipment which we need. Then measurement that the student need to carry. What measurement he will, what things he will measure? He will measure thermometer is already given, so you don't have to write. I did not check the figure. So thermometer, if it's given, you don't have to mention that. Reason thermometer is given in the figure, shown in the figure. So answer will be main equipment which we need is stopwatch and balance. Because voltmeter and ammeter is also not needed here. Why it's not needed or required? Because already they mentioned the power is P. So power is P means power is given. So what we will measure, the measurements, we'll measure time, initial temperature, we'll measure final temperature, we'll measure mass, and voltage and current is optional here. Why it's optional? Because the power is given, so you don't have to measure voltage and current. And the equation you use to calculate, so which equation we'll use to calculate? So specific heat is equals to power multiplied by time divided by mass into temperature change, which is T2 minus T1. Is it clear? This simple experiment to find specific heat capacity of block of iron. Any doubt in this?
No, sir. Sir, I have a question.
Yes.
Sir, like in this measurement, like if we measure the specific heat capacity,
Right.
the value will be greater than the original value of iron, right?
That's true. Yeah.
Sir, because like the heat is lost to the surroundings, so you'll
That's
need
correct.
more energy.
Yeah, and you need more energy, and time interval will also be more. That's right. So
Yeah.
practically, when you actual values are smaller as compared to what you are doing experimentally, experimental values will be higher. How we can overcome this if we want the answer closer to the experimental value? We don't want the heat to escape to surrounding. So what we should do?
Use
So
a
you
insulation.
vacuum flask or like
Use insulation or lagging. Like wrap this block with any insulating material so it will not lose heat energy to the surrounding. And do this experiment at like raising a temperature, because what happened, example, if I raise the temperature of a block from 20 degrees to 25 degrees, okay, that's a 5-degree change. And if I do this experiment, like the block was originally at 60 and I changed its temperature from 60 to 65, this will give me, even though both have the same temperatures, change, but this will be more inaccurate. Why it's more inaccurate? Because at higher temperature, rate of heat loss is greater. Like if you have anything hot, it will lose more energy to the surrounding as compared to at a lower temperature. So that's why we should do this experiment or change the temperature to lower value. If you change the temperature to higher values, then rate of heat loss will also increase. Is it clear, this experiment?
Yes, sir.
I'll show the marking scheme as well for discussion. This is a marking scheme. So here, mass of a block, initial temperature, final temperature, time for heater, voltage or potential, and voltage and current, and then what you're using a formula. So this is a similar question you can see here. Shows some of the operators that student used to determine the specific heat of aluminum. State the measurement needed, include those from electrical circuit as well, like mentioned voltage and current. And for each quantity, measure and state a symbol for that, like voltage denoted by V, current denoted by I, and mass denoted by M, time denoted by small t. All the so same question is there as we discuss this one. Then the second type of experiment is experiment to find latent heat, specific latent heat. So as we know, the formula, because the practical formulas depending on the things which are operators which are available to measure those quantities. So practical formulas are a bit different from actual theoretical formulas. So as we know, latent heat or specific latent heat is energy divided by mass. So practically you cannot find directly the energy supplied. So practically how you get the energy is power multiplied by time. So latent heat will be equal to power multiplied by time divided by mass. But power directly, you don't know the power. You calculate the power also in direct method. The power is a product of voltage and current. So what will be the practical formula to calculate latent heat is equals to voltage multiplied by current multiplied by time divided by mass. So this is a practical formula to calculate the latent heat. So how V is the voltage here? By voltmeter. I is the current by ammeter. T is the time by stopwatch. And M is the mass by balance. So these are the things practically you need to measure the specific latent heat of object. It can be latent heat of fusion. It can be latent heat of vaporization. So example, figure 4.1 shows an apparatus that could be used to measure the specific latent heat of fusion of ice. And the formula which we were using to practically to calculate the latent heat of fusion is voltage into current into time divided by mass. And these are the quantities which we need or required to calculate the latent heat of fusion. So describe how would you use the apparatus. You may assume that the ice at 0 and the stopwatch are available. State all the readings that you need in each stage. So how we will use this apparatus to calculate the specific latent heat of fusion for ice. So latent heat is equals to voltage. Actually, it's power multiplied by time divided by mass. So power is already given. So if power is given, we don't have to measure. We don't have to mention the value of the latent heat here. This is just an experimental procedure that how it is done or how you will get the answer. So what we will do, we will turn on the heater. And wait until constant dripping start. What is the meaning of constant dripping? Here constant dripping means that when it's a constant dripping, it shows like every second, example, 1 drop of water is coming. So that means constant dripping. And once there's a constant dripping, it means all of the ice is at its melting temperature. But for example, if you have 1 drop after like 2 seconds, another drop after 5 seconds, another drop after 3 seconds. So this is not a constant dripping. Constant dripping means same time interval, you have same number of drops of water coming out. That's called constant dripping. So once we have a constant dripping start, we are we'll be sure that this ice is at the melting temperature. So turn on the heater until there's a constant dripping start, and then record the or measure the mass. Then measure the time or record the time ice to melt, and measure the mass of water before and after, because some of the water is still there. So before and after the experiment, because the mass of the water here is actually the mass of the ice which is melted. Is it clear, this experiment? Is it clear, the experiment? Like we have the power, we need a time. So we will use a stopwatch. Once the constant dripping start, we'll start the timer, and we'll stop the timer after certain time interval, like after 5 minutes, and measure the mass before and after. Is it clear, this experiment to find specific latent heat of fusion? So,
Sir, I have a question.
yes.
Sir, like we'll measure the mass of water like before the constant dripping starts.
That's true.
Amount of water.
Yeah, the moment when the constant dripping start, we'll measure the mass at that time. And once we'll stop the experiment, we'll measure the mass again.
Yeah.
That will be the mass of the water which is melted